So here are 4 composite or shaded area problems. We did a couple of them in class today. For all of these, once again, you're either adding or subtracting various areas, and you want to start off by identifying which area formulas to use and then make a choice about whether or not you're going to add or subtract those area formulas. Then you may need to do a little bit of hunting to get all of the right dimensions, so all of the right measurements that you need to find those areas. Number 4. In the accompanying diagram, arcs AB, BC, and CD are semicircles with diameters AB, BC, and CD respectively. So what that's saying is that all of these guys here, these curves, these arcs, are half a circle. So in each case, you can extend those circles around, continue the circle, and you can see that each one of those are just half circles. So semicircle means 1/2 a circle. And it also means that the lines CD, BC, and BA, all of those line segments are also diameters of 3 different circles. So the sides of the rectangle are also the diameters of 3 circles. ABCD is a rectangle, BC is 28, AB is 14. Answers may be left in terms of pi, which means that you have a choice here of whether or not to approximate your answer or to leave it exact. My suggestion would be to leave things exact as much as possible. And we'll just go through each one of these parts. Now they've already scaffolded this for you, so a problem might just say find the area of this entire composite figure, and you would go through the steps A, B, and C, and then finally have to do D, but in this case they've sort of spelled it out for you. Do this step, and then this step. So part A says find the area of ABCD. So this rectangle right here. The formula that I'm going to use, area equals base times height. I do have both the base and the height, 14 and 28. I'll just pop those into the calculator. 14 times 28, 392. And there are no units on the diagram or in the instructions, so I'm not going to include units in my answer. They would be squared units if I were referring to specific units. So there's part A, 392. Now let's see, B, find the area of the region enclosed by diameter BC and semicircle BC. Enclosed means inside, so like there was a fence that included BC and arc BC. So what's the area enclosed? The area inside that figure, which is half a circle. So because it's half a circle, I'm going to use the area formula for a circle. Area equals pi times the radius squared, and then I'm going to divide that area into 2 equal parts. So I just need half of that area. The diameter is 28, but r, of course, is the radius, which means I just need 1/2 of the diameter. So I'm just going to need 1/2 of 28, or 14. 14 is what I'm going to plug in. Pi times 14 squared, divide that by 2. And I'm going to try to leave this as exact as long as possible. So I'm not going to put this in the calculator. I'm going to do some mental math. I'm going to leave pi alone for right now. 14 squared is 196. And then 196 divided by 2 would be, let's see, 9. 2 goes into 9. about 9 times, 19 about 9 times with 1 left over. 2 goes into 16 about 8 times. So 2 goes into 196 98 times, and it's really going to be 98 pi. So the area for semicircle BC, this space right in here, is 98 pi. There's part B. Now let's take a look at part C. Part C says find the area of the region enclosed by diameter AB and semicircle AB. So here it's this space right here. And one of the students in class today noted that these two semicircles together make one whole circle. They have the same diameter. It's a rectangle, so if the left side is 14, then the right side is also going to be 14. And those two circles are going to be, or those two half circles would together make one whole circle. So if we didn't have to didn't have to do these different parts, like didn't have to answer A, part B, part C, we could just know that together they're going to be one circle and we wouldn't be dividing it into two parts. But they have scaffolded this question for us. They do want us to find out how much that half circle is, that semicircle is. So we're going to do the same formula again. Area equals pi r squared, and we do need to divide it by 2. They just want half for the answer to C. Pi, the radius in this case is going to be 7 squared, divide that by 2. And that 7 is coming from 1/2 of 14. 7 times 7 is 49. So now it's 49 divided by 2, still times pi. And 49 divided by 2 will be, let's see, 25, 26, 27, 28 and a half. 29 and a half, 29.5 pi. So there's the answer to C. And then find the area of the entire region. So the entire region would be the rectangle plus that big semicircle plus the two little semicircles, but they're actually going to be one whole circle. The area of the rectangle is 392. The area of the larger semicircle is 98 pi. And the area of the two semicircles put together, the two little ones, is actually this piece right here, before we divide it in half, 49 pi. The 98 pi and the 49 pi are like terms. They both have a pi, which means that I could still keep this exact and make it 392 plus whatever 98 plus 49 are. So 98 plus 49 pi. 98 plus 49. 147. So my answer is 392 plus 147 pi, or I can approximate that. So 147 times pi plus 392 is about 853.8. 853.8. So there would be the area of the entire region if I was rounding to the nearest tenth. Let's take a look at 37. So in this problem, we're looking at a circle that is inscribed, drawn inside a rectangle. In the accompanying diagram, circle O is inscribed in a rectangle ABCD. Radius OP is drawn to AB. So there it is, O to P, drawn to the side AB. The length of CD is 21 inches, and they've labeled that for me already. And the length of OP, the radius, is 8 inches, and they've labeled that for me also. Find the nearest integer. So I'm not going to be leaving my answers exact. I'm going to put them in the calculator and round to the nearest whole integer. I'm first going to find the area of the shaded region, and then I need to find the circumference of the circle. Those numbers 8 and 2 are for scoring purposes. This came off of an old Regents exam, I believe. I'm not sure. This looks a little like an old style Regents question. In any case, you don't have to worry about the 8 and the 2. We can scribble them right out. All right, let's solve this problem. Let's start off with part A, the area of the shaded region. My plan is to take the rectangle's area and subtract the circle's area from that and then round. Pretty easy to find the area of the rectangle. I'm going to just do base times the height, and the base I have, it's 21. The height's just a little bit trickier to find, but not too bad. The height from top to bottom is what I'm looking for. Halfway I've got 8, right? That's my radius. But remember, you can draw that radius anywhere you'd like, all the way around the circle, and all of those radii that I just drew in, they're all equal to 8, including the one that goes from center O straight down to the bottom. So I've got 8 on the top radius, 8 on the bottom radius, 8 plus 8, or 16. So altogether my height is 16. 21 times 16 is going to give me my area. 21 times 16, 336. And here I do have units given to me in inches, so it's really 336 inches squared. There's the rectangle. Now we need to find the circle. So area formula for a circle is pi times the radius squared. And the radius of the circle is 8, so I'm going to do 8 squared. And we just want to remember that we are not going to round or anything until we get to the very last part of the problem. So I'm not going to use 3.14 here. I'm going to go 8 times 8, or 64, and just write it as 64 pi inches squared. And that would be my exact answer, but the problem specifically says find this to the nearest integer. So I'll use my calculator at this point and make sure I use a bunch of parentheses. 336, subtract, parentheses, and I'm going to put in that whole quantity, 64 times pi, close my parentheses. And it looks like it's 134.938. I'm supposed to round to the nearest whole integer, so I'm going to have to round up. 134 becomes 135. So my area in part A of the shaded region is 135 inches squared. Part B is looking for the circumference of circle O. I need a different formula for that. Pi times the diameter. The diameter is 16. We found that in the first part of the problem, so it's going to be 16 times pi, and in this case it's just inches, single units. It's a distance, not an area. And once again I have to find this to the nearest integer, so at this point, the end of the problem, I'm putting 16 times pi into my calculator. I'm getting 50.26. I'll round to the nearest whole integer. 2 the 10th place is less than 5, so I will leave 50 as it is. And my circumference is, I probably should say about for both of these problems, right? It's not equal to, it's about 50 inches. So answer 1 and answer 2. If you'd like to see either of those other two problems, either the triangle problem or number 33, the rectangle inscribed in the circle, please send me an email or post a request on Facebook. I'd be happy to put those up.